These are the solutions for the first practice quiz for quiz 7 in the third trimester of Algebra 2. You're also going to want to have the calculator soup site up because you're going to want to enter your data in there and crunch this out. So this can be found on the learning plan. Just basically you can Google calculator soup, and then you got to go to statistics and descriptive statistics calculator. And I will come to this page at the right moment. Okay, so a lot of this quiz is about the nature, especially in the last part, the third page, the nature of what outliers do to a data distribution and when you don't have outliers. So problem 1 is about a time when we don't have outliers, or there could be outliers at equal distances in both directions. So here there's no skewing, and we have a symmetric, it is symmetric, the distribution. So if we did a graph, it would look, we could put a line right down that, the median, the mean, and the mode, and then the graph would look fairly the same on both sides of that line. Number 2, the mean of the data set is well to the right of the median. What can be said about the data and the shape of the distribution? So the data definitely has outliers to the right, or larger values to the right, and it is skewed to the right. Okay, so the data set has outliers to the right. And it is skewed right. The mean is skewed to the right of the median, to be specific. So those outliers are causing the mean to be artificially inflated, pulling it to the right of the median. So the median is always going to be a true representation of the data. We want the mean in the mode to be close to the median and good sets of data. State the name of the data elements that would cause the mean to lie to the right of the median. So outliers, an outlier to the right. So you need to be specific on this. To the right, because an outlier to the left would not do that. Okay, problem 4. What is the student's overall grade? It's important that you know this. This is based on the sum of the weights used. So you're going to divide by the sum of the weights used. And typically, if you're within a, particular grading, trimester or semester, not all the weights are used. In this problem, all the weights are being used. So I'm just going to go right ahead. And can you do, points all the way? So we need to do divided by 1 here. 0.9 times 0.5 plus 0.75 times 0.2, you can. But it's real important that you understand that this is divided by the sum of the weights used. So if we only had the first 2 categories, you'd be dividing by 0.7 in the final calculation. Problem 5, the average of 6 numbers is 15. Okay, so what we need to understand is the sum over the count is the average. And that's huge in this. Okay, so the average of 6 numbers is 15. So what is the sum then? Well, we can go backwards and figure out that that sum has to be 90. 15 times 6. Okay, when 1 number is removed, so that means we're down to 5, the average is 10. So that sum must have been 50. So you need to figure out the sum over the count for both of these. And now you can figure out the value of the number that was removed is the difference between the 2 sums, 90 minus 50. So we must have removed 40 to make that sum drop to 50. All right, so here again is kind of the sum over count idea for this. So of course we're counting ducks in the end. So 50. So you're not going to want to, you know, if you need to think about this. So we're listing 8 50 times, and then we're listing 6 40 times. So this is 50 times and 40 times. So you're going to not want to do 8 plus 8 plus 8 plus 8 plus 8 50 times. I'm going to do 50 times 8 and then 40 times 6. And then the count is 90. And then this will average to be 7.1. So if you get something that's not in between 6 and 8, you did something wrong. Go back and look at your work and reassess. Okay, 2A tables. My advice to you is to do problem 7D first. Okay, so the whole given that language is very important. So you're restricting yourself to the do not speak a foreign language column right here, whatever column or row you're talking about. So this bottom number is 65. And this is the only problem that's like this on this. And that have a math grade less than 90. So 50 out of the 65. And move this down here. That's true for. And so then just turn it into a decimal and then a percent. So 76.9%, 0.769. And then turn it into a percent. So that's that odd one out. The rest of these all have denominators of 145. This total right here, this is the total of everything we're dealing with. Okay, what percentage of students speak a foreign language and have a math grade greater than or equal to 90? So we're out of 145 here. So notice the word and. So we're speaking a foreign language and have a math grade greater than or equal to 90. Okay, so we're dealing with, if you want to look at this, we're dealing with the intersection of that row and that column. That's 70. And when we divide this out, 48.3%. Now notice we changed the word and to or. So what's the difference here? So the difference is we're going to have, so when you look at, so now we're looking at these n numbers. So have speak a foreign language, so there's 80 of those. Have a math grade greater than or equal to 90, there's 85 of those. But in doing that, in taking this 80 here and this 85, we count the 70 twice, so we have to subtract it once. So we're adding these n numbers here, the column and the column and the column and then the row, and we're subtracting where they meet because we're counting that number twice. So this will be 65.5%. So add the two n numbers and subtract that intersection, and yes, this is the same. This is the way I set it up. What percentage of students have a math grade less than 90? So we're out of 145 again, and a math grade less than 90. Now we're over at 60 total out of 145. So the rest of this is just about selecting the n numbers on the edges of the table. Okay, so notice that these n numbers were selected, and then the 70 obviously is where they meet there. So notice those patterns as you study this page. It is very important. Okay, data sets and calculating these. You need to go to Calculator Soup and you need to enter in the sets of data. Okay, and I'm going to do this one time and then I'm going to just rapid write in the results so I can get to what we need to get to with this. So you just basically want to make sure definitely make sure you get everything entered in correctly. 79, 82, 393s, 2, 3, whoops, that says a 2, and a 92, 52, 53. It is a little bit tedious, but this is the best site to use. 61, 72, 70, 89, and 71. And then just go back and double check everything. Make sure you have samples selected and then hit calculate. It's going to put them in order from least to greatest. And then you're ready to write down everything. So now I'm going to, and basically all of this, you're not going to use the size or the sum. So the size is the count. But everything else through standard deviation you will use. And so I'm going to now rapidly fill in these two columns. And this is stuff that you have to do that you really won't get any points for. You just need to get this data and get it right so that you can use it in the calculations below. 93, 41, and then 14.7. And this, when you enter these in, then so you just go there and hit clear. 91, this is 12, 71 and a half, 97, 85, and 22.7. So you need to get all that data correct so that you can get these calculations correct so that you can answer problem 9, because we're really building towards problem 9. So to figure out, you know, what one of these data sets has the greater skewing. So what is skewing? Skewing is how far right or left the mean is pulled from the median due to outliers or larger or smaller values in those directions. And then the greater spread is the standard deviation, this little SX value here, relative divided by the mean. So you see these vertical bars, those are absolute value signs. So if you wanted to, it's math over to num, but all you got to do is make it positive. So let me just clear that up. All absolute value means is make it positive. So you can go get your fraction template like this, and then just do the mean minus the median, 70.5, divided by the mean. The mean minus the median divided by the mean. And so again, just make it positive. I take it to 3 places, 0.029. And you're going to do that for this side, 0.035. So data set B has the greater skewing. And then you're going to divide the standard deviation by the mean. So we can just do it this way, 14.7 over 72.6. That's 0.202. And then this is 0.329. So you can see that data set B in both cases wins that, which is a bad thing. You don't want to be the winner of a skewing measure. So slightly skewed to the right. The data spread, you usually about like 10%, 0.10 is good for the standard deviation relative to the mean. So the data set B is a little bit worse for the wear. But those are the calculations you're doing. Just remember to keep these positive, okay, because we're comparing the positive values of those. And as you do these, then you don't even need to worry about using the absolute value function. And those are the solutions for the first practice quiz for quiz 7 and algebra 2 in the 3rd trimester.